Hi, my name is Lay and I'm going to present a presentation on designing frequency control by variable droop control method in microgrid for upcoming wind battery project in a remote community of Nain, Labrador. Newfoundland and Labrador has a very high source of hydroelectric power, and province most of the energy demand is supplied by hydroelectric power. 92% of province energy demand is supplied by renewable energy sources only. And Newfoundland and Labrador has its own power grid, but there are few remote communities, 21 remote communities that are not connected with the Newfoundland power grid, and they are still relying on diesel generated energy. So diesel generated energy consume diesel, so it is very harmful to environment and it releases the greenhouse gas emission. So as it can be seen in this picture, Nain is the northmost location of Labrador, and which is not connected with the Newfoundland grid, and which is not possible to connect with Quebec link as well because of the high transmission cost and uh, long transmission line. This Nain remote community has 1210 population, and this community is 100% relying on diesel power generation, and the annual energy demand for this community is close to 9,000 megawatt hour. So Nain is very remote location of Labrador and it is relying on diesel energy source. Diesel consumption of Nain location per year is close to 2.8 million liter to supply the total energy demand of 9,280 megawatt hour annually. There are four DG sets available in Nain location, but currently the one of the DG set is having a lot of trouble, and due to high maintenance cost and the OEM is not supplying parts to that faulty DG set, government has proposed a wind battery project in Nain location. So to reduce the greenhouse gas emission and supply the clean energy to this location, of course, wind micro battery project has been proposed in Nain. And as wind generators are non-synchronous generator, they don't have inertia response. So inverter control method should be provided to control frequency deviation in Nain location with proposed integration of wind micro grid project. So increasing the renewable energy generation can definitely reduce the emission, but it also induce the instability in power system. As wind and solar are being non-synchronous generator, they don't have high inertia response. So as seen in this picture, nuclear, hydro, coal plant have their high inertia and frequency and voltage control can be done by governor control. But with this renewable energy, PV, wind, they don't have inertia response, so inverter control method should be applied to control frequency and voltage deviation. Microgrid frequency is governed by the balance between the active power flow input into the grid by the generator and the power consumed by the load. And microgrid voltage is governed by the balance between the reactive power flow input into the grid by generator and the reactive power consumed by the load. So system frequency and voltage regulation is balanced between the demand and supply of active and reactive power flow respectively. So this is the system modeling that we have used to create our MATLAB simulation model. So here inverter is connected with the LC filter and that is further connected with the load. The load side current and voltage has been measured and that converted into ABC to DQ reference form to calculate the power at grid side, and phase loop lock system is also implied to have the power calculation in terms of frequency and the reference angle. So this power calculation is done and that is compared with the reference active and reactive power generated by adaptive droop control, and the error is sent to the power PI controller and the output of power PI controller is further sent to the current PI controller, and the output of that current PI controller is further converted into the DQ reference, and then the gate pulse is generated for this inverter. So the Simulink model of droop control is constructed in MATLAB Simulink to check the frequency control of a proposed wind battery in Nain Labrador location. The existing diesel generator is 1.5 megawatt, which is modeled in MATLAB with 2.5 megawatt of wind farm. And there is a transformer also connected with the diesel generator, which is 400 volt on primary side and 600 volt on secondary side. So as we have proposed frequency control by droop control method, so it is very important to set the frequency droop set points and the voltage droop set points as well. So as shown in the figure, if active power increases, frequency get decreases, and vice versa. If active power get decreases, frequency increases. So droop control maintain frequency in between frequency set points. So in MATLAB simulation, we have set frequency set points at 1% deviation. So frequency can vary from 59.7 Hertz to 60.3 Hertz. Apart from that, active power also can vary 10% from its rated output. So in upcoming slide, I'll present the simulation. So this is the MATLAB simulation block diagram which is carried out in MATLAB Simulink. So this block diagram represent existing diesel capacity which is 1.5 megawatt. This is the MATLAB inbuilt diesel generation system, and this is the wind farm of 2.5 megawatt, which this both are connected with the point of common coupling, and there is a load also connected with that. And I have added the variable load with that to check the dynamic condition with increasing load as well. So this is the control diagram, control system for this wind and diesel hybrid system. And these are the measurement that we are carried out: frequency, active power, reactive power, and grid voltage. So in this simulation, we are going to increase load at 1 second, and group control will enable at 3 seconds, and supervisory control enable at 5 seconds. So these are pre-data entered in this control diagram to check the simulation effect on this wind diesel hybrid system. So in block diagram of 2.5 megawatt wind farm, this is a submodel of that wind farm. So there is a two-level converter which is connected with the LC filter, and that is connected with the transformer which is 480 on primary side and 600 volt on the secondary side. The gate pulse of two-level converter is given by this control system. So we are converting ABC grid voltage to DQ reference voltage, and from that PI controller we are supplying gate pulse to this two-level converter for controlling the frequency of the grid. So this is the frequency deviation captured during simulation of 8 seconds. So as there is a load increase at 1 second, you can see the frequency deviation, and at 3 second group control is in act now, and at 5 seconds supervisory controller is enabled. So as you can see, the frequency deviation is within the limit of 1% of droop set points, and when supervisory control gets on, frequency try to reach 60 Hz at a steady state value. So from this simulation result, it shows the point of common coupling bus voltage. So this is the grid voltage of point of common coupling, which is maintained at 600 volt. Uh, just because of group control and supervisory control when there was an increase in load. So it shows the grid voltage maintained within the set point set earlier. This is the simulation result of active and reactive power of grid. When there was increase in load at 1 second, active power and reactive power both increases, and the active power increases from 1200 volts to 1600 volts. So from the earlier result of frequency and voltage, we can see the frequency stability is within the range, and voltage is also within the range. So to conclude our presentation, Nain is of course very remote location in Labrador, and which is not connected with the Newfoundland grid and Quebec grid as well. And it is not possible to connect with Newfoundland grid or Quebec grid because of high transmission cost. So with this upcoming wind battery project in Nain, there is a high renewable energy penetration in this microgrid. So it will be having issues of frequency regulation and voltage regulation if we have a high penetration of renewable sources. So with this droop control inverted microgrid method, it is simulated that the frequency variation and the voltage variation is within the set point, and that can be effective solution to control frequency and to maintain voltage across the grid. Finally, thank you for listening our presentation and have a good day.